Okay, so we're going to do a LeetCode problem. Walls and gates. So you're given by n grade rooms initiated with these three possible values. -1 means a wall, obstacle. Okay. 0 means a gate. I and F means an empty room, and we use the value to represent I and F, as you may assume that the distance to the gate is less than I and F. Okay, for each empty room with the distance to its nearest gate, if it is impossible to reach a gate, should fill with NF. Okay. For each empty room is the distance to its nearest gate. So for me, since we wanted to fill each empty room with nearest gate, I think about using BFS, and the starting point of those BFS are multi-source BFS. So all the gate is a starting point, and we do this BFS on the starting point and fill in the numbers, which is the distance, show the distance of the empty room accordingly. The idea is quite simple. I think I can code it up. Okay, I use a queue. Pretty simple. Oh. Visited. Is distance of the rooms. We got a set. So we start with we add all the start point into the queue. I don't see the point using model. J range n. So if grade, if rooms if this is an infinite, okay, that's it. What the input looks like, right? Better to define what is I and F. So if the room's ij is infinite, that means we are going to add it into the queue. That's a valid starting point. Wait. I'll just add the address, it's fine, right? What am I going to add to the queue though? ij, because eventually I'm going to return eventually I'm going to return the rooms, right? Do I need to return anything eventually? Okay, I need to fill the empty room. Okay, I see. So how I fill the empty room is that I definitely need to know the distance. And current distance is 0. I'll just update the distance. Whenever I hit empty room, I update it first with a number. Is that right? I think so. And also not forget to add it into the visitor. Okay, in this case we started to also we need to define the direction it can go. That's where we get the child node. In this case, because it's only up, right? It's only up, right? Left, right, up, down, left, right. So up, let's do up. Delta would be -1. Okay. Also, I use BFS. What BFS we got? IJ and distance, and then the current one. How are we going to do this? I think I'm going to find what is the next new ones, and for the next new ones I'm trying to see whether this is an empty room. If it's an empty room, I'm going to just update. I want update, always thinking about at bound. So I'm going to just try each of the direction. The new I becomes I plus di. And new j becomes j plus delta J. Let me check if the new J, if the new I is smaller than M. Larger or equal to 0. We check whether it has been visited, and check if it is a valid empty rooms. We only expand empty room it's okay, just okay. If that's the case, we just we're going to just add it into the visited one. New I, new J, and also at the same time append it to also we need to update the rooms, right? Rooms, new I, new J, it now becomes the distance plus 1. Also, do not forget to add it into the queue. Okay, so we only going to 0 as a gate. The gate should be added. Okay, and also J should use N. Okay, this is not defined. Why the? Okay, we're going to add it into the function itself. Awesome, it works. So let's think about the complexity. So for the time complexity, it'll be m and n, because for each of the node, it must get into the queue once, and then get out of the queue at most once. So the total operations is smaller, is bounded by m by n. And for space complexity, the worst case is that store all the, so it will be m by